Hi guys, this is lesson 4 in Unit 8 and today we're going to talk about the vertex form. So let's start by saying what is the quadratics vertex form. The quadratics vertex form is y equals a times x minus h squared plus k, where a, h, k are real numbers. A, h, k are real numbers. Now, the number inside the parentheses with the x, which is h, and the number outside of the parentheses, or outside of x, added to x squared, which is k, represent the coordinates of the vertex. So h, the numbers h and k, are the coordinates of the vertex of the parabola that represent this equation. So let's take an example. If we have y equals x minus 1 squared plus 2, this quadratic equation can be represented by a parabola. This parabola has a vertex of 1, 2. Another example is y equals negative times x plus 2 squared plus 5. This quadratic equation has a vertex of negative 2, which is the opposite of 2, because we have a plus sign, and then 5. So the vertex that belongs to this parabola is negative 2, 5. We use completing the square, which is a technique that can change the standard form of the quadratic to the vertex form. And this is what we're going to learn today. We're going to learn how to go from the standard form, which, as we learned before, is ax squared plus bx plus c. This is the standard form, and we're trying to use a technique called completing the square to change the standard form into the vertex form that we have here at the top. So let's take a look at our first example. We have to change the standard form of this quadratic into the vertex form. And I'm going to use completing the square to be able to change the standard form into the quadratic form. And there are certain steps that you need to take to be able to do this correctly. So let's start. I need to make a perfect square to be able to have the vertex form. That means, this is what I'm going to have to do. I'm going to have to take the first two terms of the quadratic and make a space after that to add a number that allows me to have a perfect square, and move the 3 away a little bit. Now, the number that's supposed to be here in the space is half of the middle number here, which is negative 2. So I have negative 2 as the middle number of the trinomial that I need to get. And I need to divide that number by 2. That makes me have negative 1. And then after that, I need to square that number, which gives me 1. So I'm going to add 1 here, and I'm going to take away 1 from here. Now 1 minus 1, or 1 plus negative 1, is 0. So although I added 1 and negative 1 to the equation, it's like I added nothing, because the value of these two numbers added to the equation is 0. But this technique will help me have a perfect square. Why? X squared minus 2x plus 1 can be factored into the following. Y equals x minus 1 times itself. And the value of 3 and negative 1 together is 2. So now, since I have x minus 1 multiplied by itself, that means I'm going to have a perfect square of x minus 1 squared. And then all I need to do is to bring down the 2. So I'm done. This is the vertex form of the standard form for this equation. The vertex for this parabola is going to be 1, which is the number inside with the x, and then 2. And this is how we change the standard form into the vertex form. Now let's check if our work is correct or not by checking the vertex in the calculator for that equation. We have x squared minus 2x plus 3. Looking at the graph, we'll find out that the vertex for the parabola that belongs to this graph is, looking here, it's 1, 2, and just to make sure, I can check using the table of values to look at the values of the rainbow and check the vertex in the middle. And if you look at these values, you'll find out that 1, 2 is indeed in the middle of the rainbow that belong to the graph. That belongs to the graph, and the vertex is in the middle here, which is 1, 2. So our work is correct. Now let's take a look at another example where we have a different leading coefficient than 1. And in this case, we have a negative 1 as the leading coefficient. I'm going to try to use the same technique, completing the square, to be able to change the standard form into the vertex form. So the first step again is to have some space between the second term of the quadratic and the last term. So I'm going to make a space after negative 4x, and then put the 1 away a little bit. And then the second step that I need to think of is looking at these two terms, the first and second. I see that I don't have 1 as a leading coefficient. So the second step here is to get rid of that number next to x squared, which is negative 1. And the only way that I can get rid of that negative 1 is by taking negative 1 as a greatest common factor between x squared and negative 4x. So I'm going to end up with negative 1 as a greatest common factor, and then multiply that by x squared plus 4x. And this is completely fine, just for the fact, if I multiply negative 1 back inside the parentheses, I'm going to end up with negative x squared minus 4x. But this technique will allow me to have a leading coefficient of 1 next to x squared, and makes completing the square a little bit easier. So now all I need to do is to think about the number that I want to put inside with x squared plus 4x to have a perfect square. And as we said before, we're going to take the middle number of the trinomial, which is 4 in this case, and I'm going to divide that number by 2, which makes me have a 2. And then I'm going to square that number. 2 squared is 4. So all I need to do to have a perfect square is to add 4 to x squared plus 4x. So I'm adding a 4 here in the parentheses. And we have a -1 outside of the parentheses, which makes 4, if I want to get rid of the parentheses, a -4. And the opposite of -4 is 4. That means I'm going to have to add 4 outside with the 1. Again, we have a -1. The -1 outside the parentheses will make the 4 inside the parentheses a -4. And if we add a -4 to the 4 that we added at the end, we're going to end up with 0, which means we did all this, but at the end, the value of the equation stayed the same. So now, I have a -1, and I can factor the trinomial or change the standard form into the factored form, because x squared plus 4x plus 4 can be factored into x plus 2 times x plus 2. And then outside I have 1 plus 4, which is a 5. X plus 2 is multiplied twice or multiplied by itself, which means that I can write this as x plus 2 squared and add the 5. And now I have the vertex form for this equation, which is -1 times x plus 2 squared plus 5. The vertex for this parabola or this equation is going to be the opposite number of the number inside with the x, which is a -2, and then the exact number that is outside of the parentheses, which is 5. Now let's check the vertex in the calculator to make sure that we did this correctly. So I'm going to put -x squared minus 4x plus 1 in the calculator, and I'm going to check the graph. Looking at the graph, I supposed to see -2, 5 as my vertex. And if we look here, we'll find out that -2 belongs to the maximum. 1, 2, 3, 4, 5. So the maximum or the vertex in this case is -2, 5. Let's just confirm looking at the table and checking the table of values. Let's try and find the values of the rainbow that belong to this quadratic. And if we look here, we see that rainbow of values, and in the middle of the rainbow is the vertex, which is -2, 5, which is exactly what we got when we completed the square.